this lesson, we're going to use the intermediate value theorem to help locate real zeros of polynomial function. The intermediate value theorem. If f of x is a polynomial function with only real coefficients, and if for real numbers a and b, the values of f of a and f of b are opposite in sign, then according to the intermediate value theorem, there exists at least one real zero between a and b. In this example, we're asked to use synthetic division and to graph to show that the given function here has a real zero between 2 and 3. So to find if there is at least one real zero between 2 and 3, we're going to have to use synthetic division to find f of 2 and f of 3. So these, you're going to first do the synthetic division with the 2 as you're outside of your divisor, and here we have our coefficients. So let's go ahead and start that process. All right, so we're going to bring down a 1, multiply that with 2 to get 2, bring down a 0, multiply that with 2 to get 0, bring down a negative 1, multiply that with 2 to get negative 2, bring down a negative 1. So here we see that f of 2 equals negative 1. And now let's find f of 3, so we can see if there exists at least one zero between them. So let's go ahead and put 3 on the outside as our divisor and our coefficients inside. So I'm going to begin by bringing down a 1, multiply that with 3 to get 3. Bring down a 1, multiply that with 3 to get 3. Bring down a 2, multiply that with 3 to get 6. Bring down a 7. So notice here that our output f of 3 equals 7. And because our outputs here of f of 2 and f of 3 are opposites in sign, that is proof that there exists at least one zero between 2 and 3, and that is the intermediate value theorem. Okay, so in this example, we're asked to evaluate the function to show that there's at least one real zero between -5 and -4. Now, of course, as we showed in the previous example, that you're going to use the synthetic division. You're going to plug in to find f of -5 and see what your output or your remainder is, and do the same thing for -4. And if they're opposites in sign, then there's proof that there exists at least one zero between them. But I just wanted to show that there's another method that you can use where you can simply take each one of the numbers one at a time and evaluate them. In other words, plug them into the function. To find f of -5, that would mean that you're going to remove all of the x's and replace them with a -5. Do the math and see what your output is going to be. Do the same thing for f of -4. Remove all the x's, replace them with -4. Do the math and see what your output will be. If the output for both are opposites in sign, then that is proof that there exists at least one zero between them. So let's go ahead and plug them in and do the math. Again, this is an alternative method to doing synthetic division. As far as why would you want to do this method, well, it really doesn't matter one way or the other. I honestly think synthetic division might be quicker than actually plugging it into the function, but whichever method you prefer, you can certainly feel free to use that. So again, starting with -5, plugging that in place of x. When I continue to do the math, I get an output of -18. So I'm going to do the same for f of -4. Plug in -4 in x's place. My output, when I do the math there, is going to give me a +7. And again, here, notice that our outputs are opposites in sign, which proves that by the intermediate value theorem, there must be a real zero between -5 and -4. Okay, now it's your turn. I want you to use the intermediate value theorem to determine whether the polynomial function has a zero between the given integers. So you're going to see if there is a real zero between 4 and 5. You can either use the synthetic division to evaluate the function, or you can actually evaluate it algebraically. So go ahead and pause the video, and then when you're ready to reveal the answer, you can restart the video. Okay, so if you did it correct, the correct answer choice should be C.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.